All right, here we go. First video for the second semester. We're going to start with a very basic geometry topic, solving right triangles. So we're just going to use SOHCAHTOA. Now, first thing you can see I have written in red, make sure you're in degree mode. Probably from taking the midterms and the whole first half of the year, you were in radian mode. So make sure you go on right now and change that and put it in degree mode. Okay, just a review of SOHCAHTOA. You have it up there in the blue. Sine is opposite over hypotenuse. Cosine of an angle is the adjacent side over the hypotenuse side, and tangent is opposite over adjacent. Now, it's real important when we do these, and later we're gonna work with word problems. When we have the triangle, we'll always use triangle ABC. When we set up the triangle, let's always make C the right angle. And then it doesn't really matter where we put A and B. Now, when I put the angles are always going to be uppercase. Now, the side opposite, so if I use the arrow right here, the side opposite angle A, I'm going to say this is little a, or side A. So this is little a. The side opposite angle B, we'll say this is little b, and the side opposite the 90-degree angle is little c. The reason why we use that is because of Pythagorean's formula. It's always a squared plus b squared equals c squared. Little c is the hypotenuse. So if you see uppercase letters for this, we're dealing with angles. If you see lowercase a, b, or c, we're dealing with the sides. Now, if I actually use this, if I used angle A right here, well, little a would be the opposite side, little b would be the adjacent, and little c, this is always going to be the hypotenuse, always, no matter if you look at angle A or angle B. So if I use that, sine of A, well, this is opposite over hypotenuse. This is going to be A over C, little a over little c. Cosine of A is adjacent over hypotenuse, so that's little b over c. And tangent's opposite over adjacent, so that's little a over b. Now, if I look, let's say you're given angle B. Let's say I'm given this, angle B. Now, the sides switch. So I'll just cross it out. Now, little b is the opposite. Little a is next to angle B, so that's the adjacent. And as I said, C is always the hypotenuse. So if I use SOHCAHTOA, sine of angle B is going to be, let's see here, B over C. Cosine of angle B is adjacent over hypotenuse, so that's A over C. And tangent of B is opposite over adjacent, so that's B over A. All right, real basic stuff right there. Okay, let's take this, let's apply it. We're going to do 3 problems, and then we'll do the other 3 in class tomorrow. So let's look at number 1. Okay, number 1, let's see here. Let's first draw the triangle. We have angle A. Let's make this as C. Let's make it A, B. Angle A we're given is 49 degrees, so I'll put 49 in. Little a is 7. And it's saying solve for triangle ABC. So what that means is I want to solve for all the angles and all the sides. Well, the one good thing about this, when you draw the picture, the first thing you could do, very easy to get an angle measure, is get angle B. Well, angle B, that's just going to equal, you know all the angles have to add up to 180. It's going to be 180 minus the sum of 90 plus 49. Okay, when we do that, let's see here, we get 90 plus 49 is, what is it, 139. And when you subtract that from 180, we get 41 degrees. So that's real easy right there. Let's say I want to get, this side right here. Okay, this is little b. If I want to do little b, I have some options right here. Let's say you use that, let's say we use this, the 49 degrees. So if I use that, little a is the opposite, and this is the adjacent. Okay, so if I use that, I have opposite and I have adjacent, I'm going to use tangent. So tangent of 49 degrees equals opposite over adjacent, so it's 7 over b. Okay, and you wind up cross-multiplying. You could put this over 1, and it's like you're cross-multiplying, so you get b times the tangent of 49 degrees. This equals this right here, 7 times 1, which is 7. So you wind up just taking 7 and dividing it by the tangent of 49. Again, make sure you are in degree mode. So when we do 7 and we divide it by the tangent of 49, we wind up getting about, I guess this is about 6. Let's round to the nearest tenth. Let's go 6.1. So that's little b. Okay, now if I want to get c, you could use Pythagorean's formula, but let's just use another trig function. I'm going to erase what I just did to find little c. So let's get rid of this. Okay. So let's get little c. If I want to get little c, let's use the 49 degrees again. And I'm going to use the opposite and the hypotenuse. So if I'm using opposite and hypotenuse, I'm going to do sine. So I'm going to go sine of 49 degrees equals opposite over hypotenuse. This is 7 over c. And again, I get to put this 7 over 49 over 1. So this cross product is c times the sine of 49 degrees. This equals the other cross product of 1 times 7, which is 7. Just divide both sides by the sine of 49 degrees, and you're going to get what little c is. So when you do that, let's see here, you get 7 divided by the sine of 49 degrees, and we wind up getting that to be about 9.3. And that should make sense. That should be the biggest side because that's the hypotenuse. And earlier we got, I think it was b equaled 6.1. So you're going to be given 3 pieces of information. You're going to get the other 3 missing pieces. And I got angle B, 41 degrees. I got little b is 6.1. Little c is 9.3. And it's pretty much all SOHCAHTOA and using the fact that all angles in a triangle add up to 180. Okay, let's skip to number 4. Now that's kind of like the long version if you have to solve everything. For number 4, I only have to find the smallest angle. Very first thing we're going to do is draw the picture. So let's draw the picture. I'll kind of draw the picture here. I always make the 90-degree angle, angle C. So I say this is big A, this is big B. Let's see here. Little a is 10, and little b is 14. So these are the side measures. Now all it wants us to find here is the smallest angle. Well, the smallest angle, it's either going to be angle A or B, and it's going to be whatever the smallest side is. So the smallest side here is 10, so that means the angle across from it is going to be the smallest angle. This is going to be the smallest angle right here. Okay, so I want to find angle A. Now if I do that, if I'm looking at angle A, little a is the opposite side, and little b is the adjacent side. So I ask myself, which trig function deals with the opposite and the adjacent? Well, that's the TOA. So I'm going to put tangent of, I don't know what A is. I know it's the smallest angle, but that's what I want to figure it out. And tangent of A equals opposite over adjacent, so it's 10 over 14. And then now, what's different for this, which I didn't do for number 1, if I have to find the angle measure, this is where you have to hit inverse tangent or you hit second tangent on your calculator. So this is actually what you put in. You hit inverse tangent and you put in 10 over 14. So whenever you do like inverse tangent, inverse sine, or inverse cosine, that means you're finding the angle on the triangle. Okay, when you do that, so let's do it. I'm going to hit second tangent and put in 10 divided by 14. And I wind up getting this to be about 35.5 degrees. And that's it. That's the smallest angle in the triangle. Okay, let's do one more. Let's do number 5. Okay, number 5. Again, let's draw the picture. I'm going to make angle C the right angle. Let's make big A, big B. We're given little a is 7.44. And we're given angle B is 15 degrees. Now this one says the opposite. It doesn't say smallest angle, it says smallest side. But smallest angle and smallest side, they go hand in hand. Now if you look, the smallest angle is going to be this. It's going to be angle B. Angle A, let's see here, angle A and B are going to have to add up to 90. So if you did 90 minus 15, angle A would be 75 degrees. So that means this side right here, this is going to be the smallest. Oops. This is going to be the smallest side because it's opposite the smallest angle. So all I have to find there is little b. Now let's use this. You could use 75 degrees as well. I'm going to use 15 degrees. So if I use 15 degrees, this side that I want to find, little b, is the opposite side. And this 7.44, that's the adjacent side. So I'm going to wind up using the same trig function. I'm going to use tangent because I have the adjacent and I want to find the opposite. So I'm going to do tangent of, I use 15 degrees, opposite of 15 degrees, let's say is this little b, and I put it over the adjacent, which is the 7.44. Now this is a little bit easier. If I make this a proportion, I put this over 1. When I cross multiply here, I get b times 1, which is just b. I cross multiply here, and it's 7.44 times the tangent of 15 degrees. Now, see how I have it listed here? Make sure you put this first. Don't put the 7.44 here, because that means you would multiply the 15 degrees by 7.44. Leave the 15 degrees as it is, so we don't want to do this. So just put it in as how I have it written right here. So you're putting 7.44 times the tangent of 15 degrees, and you get that to be, let's say it's like 1.99. So if I round it to the nearest tenth, let's just put 2.0. And that is the smallest side. Okay, so a lot of this we're doing SOHCAHTOA. It's all review, basic stuff. You know all the three angles. They add up to 180 degrees. The one thing we didn't do on this, but you can do, if you have two sides, you could use Pythagorean's theorem to find the third. I didn't do it on any of these, but like I said, this is review. Everything second half of the year is going to go back to SOHCAHTOA. It's going to go back to right triangles.